Hi students, today we are going to see about singularities, residues, Cauchy residue theorem. First, we are going to see what is singular point. A point z is equal to z0 at which a function f of z fails to be analytic. Then that point is called as singular point. We know what is analytic function. An analytic function is that a point when its derivative exists, then you call it as analytic. Here, when it is fails to be analytic, you call it as a singular point. F of z is equal to 1 by z minus 3. Here, z is equal to 3 becomes your singular point. Next is poles. If we can find a positive integer n such that limit z tends to a, z minus a whole power n f of z is not equal to 0, then z is equal to a is called a pole. Example, we have f of z equal to 1 by z minus 4 the whole square, z minus 3 the whole cube, z minus 1. Then we'll define what is the pole and what is the order. Always order is represented by the powers. Here z is equal to 1 becomes a simple pole of order 1. Z is equal to 4 is a simple pole of order 2. Z is equal to 3 is a simple pole of order 3. Next is residue. Residue of f of z at z is equal to z0 is always denoted by residue of f of z at z tending to z0. Some of the evaluations of residues. If you need to find the residue of a pole of order m, okay, then if z is equal to z0 is a pole of order m, then the residue is given by residue of f of z at z tending to z0 is equal to 1 by m minus 1 factorial limit z tends to z0 d power m minus 1 divided by dz power m minus 1 z minus z0 whole power m f of z. When it is for a simple pole, that is of order 1, then you have the residue as residue of f of z at z tending to z0 is equal to limit z tends to z0 z minus z0 f of z. We'll see a simple problem based on this. Find the residue of f of z which is equal to z by z minus 1 whole square at its pole. F of z is given as z by z minus 1 whole square. That is z is equal to 1 is a simple pole of order 2. Here m is 2. I have written the formula, then we are going to substitute. Residue of f of z at z tending to 1 is equal to, instead of m, replace it as 2. So 1 by 2 minus 1 factorial limit z tends to 1 d power 2 minus 1 dz power 2 minus 1 z minus z0. Here z0 is 1, so z minus 1 whole square. F of z is z by z minus 1 whole square. Both these gets cancelled. We'll have 1 by 1 factorial limit z tends to 1 d by dz of z, which is limit z tends to 1 of 1. Answer is 1.